James Webb Space Telescope. Source, NASA, ESA, CSA. By visualgk.com. On the 11th of July 2022, U.S. President Joe Biden unveiled the first deep-field image, captured by the James Webb Space Telescope, revealing galaxies as they appeared some 13 billion years ago. Unveiling the image, Biden called the moment historic. It's astounding. It's an historic moment for science and technology, for America and all of humanity. The mission. The James Webb Space Telescope, Webb, is the next great space science observatory, following Hubble, designed to answer outstanding questions about the universe, and to make breakthrough discoveries, in all fields of astronomy. Webb will see farther into our origins. From the formation of stars and planets, to the birth of the first galaxies, in the early universe. Webb is a partnership between NASA, ESA, and CSA. Parts of Webb telescope. Six sides to the Webb telescope. James Webb Space Telescope studies every phase of cosmic history. The Webb telescope is the scientific successor to the iconic Hubble and Spitzer space telescopes, built to complement and further the discoveries of Hubble, Spitzer, and other NASA missions, by accessing the near-infrared and mid-infrared wavelengths, with unprecedented resolution. Webb's revolutionary technology will allow scientists to explore every phase of cosmic history. From within our solar system, to the most distant observable galaxies in the early universe, and everything in between. Webb will reveal new and unexpected discoveries, and help humankind understand the origins of the universe, as well as our place in it. The Webb Observatory is so large, it was folded up for launch, and then unfolded in space. Webb's science objectives required the observatory to be very large. So large, that when expanded to full size, it couldn't fit into the nose cone of any available launch vehicle, in its operational configuration. One of Webb's main components is the sunshield, a diamond-shaped structure, roughly the area of a tennis court. It was carefully folded and packed, to fit inside Webb's launch vehicle, the Ariane 5 rocket. In space, the sunshield expanded, and separated into its 5 distinct layers. At over 21 feet in diameter and about 270 square feet in area, Webb's primary mirror was also too wide, to fit into the Ariane 5 in one piece, so it was segmented into 18 hexagonal pieces on a hinged structure, so it could fold up for launch. It is the largest mirror ever flown into space. JWST primary mirror versus Hubble primary mirror. Webb has taken a million-mile journey to reach its destination, to orbit the Sun in line with Earth. This special orbit allows one side of Webb's sunshield to always face the Sun, Earth, and Moon, blocking their heat and light from reaching the telescope's heat-sensitive optics. Webb's month-long journey took it to the second Lagrange point, one of 5 positions in space, where the gravitational pull of the Sun and Earth balances the centripetal force required for a spacecraft to move with them. This makes Lagrange points particularly useful for reducing the fuel required for a spacecraft to remain in position. The location also enables continuous communications with Webb, through the Deep Space Network, an international array of giant antennas, managed by NASA's Jet Propulsion Laboratory. Lagrange points. They are places around a planet's orbit, where the gravitational pull of the planet and the Sun, and the motion of the orbit combine to create an equilibrium, requiring very little energy, to stay in orbit. Webb's state-of-the-art scientific instruments are engineered to produce a treasure trove of awe-inspiring imagery and data. The instruments primarily have two functions. 1. Imaging, or taking images of scientific targets. And 2. Spectroscopy, or breaking down light into separate wavelengths, like raindrops create a rainbow, to determine the physical and chemical properties of various forms of cosmic matter. Webb's science instruments. Several new technologies were developed during the building of the Webb telescope, including innovative spin-offs that have already improved life here on Earth. In designing Webb, engineers had to imagine a telescope unlike any that has ever been built before. Technological advances, and even new inventions, were necessary to make the mission feasible. Breakthrough lightweight deployable mirrors, and advanced composite structures that align to millionths of millimeters, and work at super cold temperatures. Large, ultra-sensitive infrared light detectors. A micro-shutter device, with thousands of tiny windows, each the width of a human hair, and programmable to be open or closed, to enable spectroscopic measurement of hundreds of individual objects simultaneously. A cryocooler that chills the mid-infrared detectors to the necessary temperature of only a handful of degrees above absolute zero. Some Webb developments have had serendipitous spin-off benefits. One example assists surgeons performing LASIK eye surgery. Engineers developed a technique for precisely and rapidly measuring the mirrors to guide their grinding and polishing. This technology has since been adapted to creating high-definition maps of patients' eyes for improved surgical precision. First full-color picture from the new James Webb Space Telescope. Specks of light from ancient galaxies, whose light traveled 13 billion years to reach us, sparkle in this first image, released from the James Webb Space Telescope. The composite of images is the deepest view of the universe ever captured. Please like, share and subscribe. visualgk.com